Hello everybody, my name is Martin Leahy. I'm a Maxon UK and Ireland sales engineer, and today I'm going to present DC drive systems for micro e-mobility. So first, a little bit about Maxon. Maxon are a family-owned business since 1961. We have our headquarters in Switzerland. Over 3,000 people work for Maxon worldwide at 9 production sites, and we have subsidiaries in over 40 countries. The Maxon manufacture about 5 million motors per year in 16,000 different variations. Our key technologies include 5 winding technologies. We manufacture our own gearheads, sensors, controllers. We have injection molding departments in the form of metal, ceramic and plastic. And we also have a battery department to complement the business. I'll speak about the battery department a little bit later on. So at Maxon, we like to combine all our products into fully mechatronic drive systems where possible. In order to do this, we place a substantial emphasis in research and development, and over 200 people work in R&D back at the factory. And the duties of the R&D team is not just to develop new products, but also to work closely alongside our customers to realizing their applications. So what is micro e-mobility? It's sort of a term that's loosely defined, but it's typically for travel solutions for short distances, usually the first or last mile of a journey. These systems have a speed capability of less than 25 kilometers per hour. They employ an electric powertrain and have a payload capacity of less than 500 kilos. So typical application examples include e-bike systems, electric scooters and trikes. But at Maxon, we also consider electric wheelchairs, rehabilitation vehicles, and mobility scooters into the overall mix. So drivers and barriers, I'm sure a lot of you are well aware of these. We have an aging population, so this cohort of people is going to look to maintain their independence for as long as possible, and micro e-mobility might offer a solution to do this. The COVID-19 pandemic has seen a significant shift away from public transport. Micro e-mobility can kind of be perceived as less risky as there's fewer contact points and it's kind of easier to maintain your social distance. I read an article there a couple of months ago that even though traffic in Ireland is back to pre-pandemic levels, public transport is still down about 50%. Urbanisation, as more and more people move into our cities and towns, they're going to look to move about the cities efficiently, and micro e-mobility might offer a solution for some people. Environmental concerns, as these devices use an electric powertrain, they can be deemed as relatively environmentally friendly in comparison to fossil fuel alternatives. Flexibility, so you don't have to adhere to bus timetables, flag down taxis, look for parking spots, etc. These devices can be so compact almost that you can bring them into the office with you as well. And finally, it must be mentioned that they're an affordable method of transport, especially when we're seeing rising fuel costs at the moment. More and more people will be looking at these devices to get to and from work. Barriers include the current lack of regulation. Infrastructure is an issue, or lack of. E-waste is a concern, especially with the lower end systems. Some of these lower end systems have a service life of anything from 100 to 150 hours before they're making their way into our waste streams, into our landfills and into our recycling centres, etc. Safety is also a concern, both operational and device safety. From an operational standpoint, this kind of feeds back into the lack of infrastructure, but also you're not as well protected on these systems as you might be in your car or bus, etc. From a device standpoint, any system that uses a battery runs the risk of catching fire. So why would you consider DC drive systems? Well, the job of the DC drive system is to convert electrical energy from the battery to mechanical output. DC drive systems offer low power consumption, and they're said to be the most efficient form of rotary motion when you're using battery devices. DC drive systems also have simple control characteristics. The speed is directly proportional to the voltage, and the torque is proportional to the current. So DC drive systems also offer a high starting torque, maybe in comparison to AC systems. And when they're designed correctly, they can be very lightweight, maintenance-free, and resistant to vibrations, shocks, and extreme temperatures. So you've begun your project. There's a number of questions you have to answer. before you can fully specify a motor, etc. How fast does the load move? What are the max accelerations? What is the continuous and max torque? How long do each of the individual phases last? And what are the typical usage demands? What environmental and ambient conditions will the motor be expected to work in? And finally, it can never be discounted. What is the target market and the target price for your device? So essentially, there's two types of motor that are used in e-mobility systems. There's the brushed and the brushless DC motor. The brushless DC motor is also known as a BLDC or an EC, which stands for electronically commutated. So the brushless DC motor is a newer technology. It was developed in the 1970s, and it's often said to be more efficient, have better power to weight ratios. It's more durable, it tends to run a little bit quieter, and it's also less prone to overheating. So obviously one of the major differences between the brushed and the brushless DC motors is the service life. So if we take a look at the brushed motor on the left, the brushes will wear down due to friction. And this can cause the voltage to act irregularly and you can end up damaging the motor. So under worst case scenario, your motor might only last 100 hours, and then under optimum conditions, it can last 10,000 hours plus. With a brushless motor, the brushes have been replaced with a PCB at the back of the motor, and this alternatively powers each coil. So with the brushless DC motor, the service life is a little bit more predictable, and it's down to the ball bearing life. So you can get anything from 10,000 hours plus with the brushless DC motor. It must be mentioned that brush motors do have their advantages. They offer simple operation and control. There's less complex cabling. And because they're mass produced, they're often very cost effective in comparison to the brushless alternative. And also with the brushless motor, it might be high speed, and that might require a gearhead then as an additional cost. So there's two types of windings also to consider, the iron core and the ironless winding. Both have their advantages and disadvantages. The ironless winding is more suitable for demanding applications. It offers higher dynamic performance, a higher power to weight ratio, a longer service life, and linear speed and torque control. It also offers low vibration and noise, and is highly efficient. Efficiency is very important because when you can achieve an increase in your motor's efficiency, this leads, it's further compounded by the battery essentially, which leads to more distance, less charging times, and also extends then the service life of your overall system. Again, iron core windings have their advantages. They're mass produced, so they're cost effective. And they can tolerate thermal overloads better than the ironless winding because the iron core essentially acts as a heat sink and kind of aids heat dissipation. So one of the major ones again is the iron core winding is a lot cheaper than the ironless winding. So people might be considering two types of drives, a direct drive motor or a geared motor. The direct drive motors tend to be heavier and larger, and they require more energy to pick up speed. When you gain the momentum, you can then achieve a higher max speed, but they're not particularly well suited for start-stop traffic, hilly terrains, cargo bikes, etc. So with the geared motor, they offer a higher low-end torque, which is very useful, obviously, in difficult environments, hilly terrains, etc. They can be very compact and light in comparison to direct drive when designed correctly. One of the disadvantages, they might have a lower top speed than the direct drive alternative, and they might also have a shorter lifespan due to the mechanical wear of the gearhead. We kind of suggest maybe considering planetary gearheads because they're quite efficient. So with a single stage planetary gearhead, you can achieve efficiencies in excess of 90%. IP protection or ingress protection is also very important. It's basically your device's ability to withstand dust, dirt, solids, and liquids. Most warranties, even with a high IP rating, most warranties will not cover water damage. So most scooters, e-bikes, etc., seem to have an IP rating of IP54. So the 5, which is basically the first digit, is the resistance to solids, and the 4 is the device's resistance to liquids. So with an IP54 rating, your device can withstand dust and dirt ingress, and then the liquid, it can only withstand splashing water ingress in terms of liquids. So you might also see an IPX4 rating, and the X in the IP rating means that essentially your system was tested for splashing water, but it wasn't tested for dust and dirt ingress. It doesn't mean it can't withstand the dust and dirt ingress, it just means it wasn't recorded. So battery systems. The battery system is essentially your fuel tank. Most high-end mobility systems will use a lithium-ion battery due to their capacity and energy density and longevity. At Maxon, we kind of got into manufacturing batteries through our e-bike program. We had great difficulty sourcing batteries from our suppliers, so we decided to go out on our own. This wasn't a very easy task as you need a great deal of technical expertise, and you also need a lot of specialized equipment. So the golden rule with battery systems is to lower the size, the weight, the charging time, the price, and also increase their safety. Again, there's a number of questions you have to answer before you can kind of specify your battery system. What is the capacity of the battery in watt hours, the voltage, the continuous current, the max current and duration, possible charging times, and the number of cycles required, i.e. the service life of the battery. So when all your cells are professionally glued and wired together, you're not finished then. You're also going to require a battery management system, or the BMS. And the job of the BMS is to supervise the battery, the charging and the discharging procedures to avoid overcurrent, surcharging, depth discharge, and too high temperatures. And the BMS will also provide communication with your host system, which is important. So at Maxon, when we start a project with a customer, we like to start them off with standard components. The standard components, the motors, gearheads, sensors, coders, etc., controllers, they basically constitute the basic building blocks for what could be very complex applications. And we like to start with the basic components because you can test the technology, avail of shorter lead times, and you don't have to pay for tooling, obviously, etc. We also have semi-customized products available from our website, or X drives, as they're also called. And with the X drives, you can modify the motors to suit your application. So you can extend the shaft, put a keyway on the shaft, change the mounting arrangement, change the cabling length, add a connector, etc. And then finally, when our customers kind of test their products initially, we like to develop fully customized products that are perfectly matched to their requirements or needs. So the Bike Drive Air, I want to consider a couple of case studies. The Bike Drive Air, we're all well aware that e-bikes are conquering our cities, towns, etc. Many existing systems, however, can be kind of sluggish and heavy, and Maxon kind of wanted to set about changing this, so developed the Bike Drive Air. It represents 60 years of experience in development of motors, controllers, sensors, etc. And its centerpiece is a mid-mounted EC motor. EC motor is combined with an ultra-performance gearhead, and the total weight of the system, including the batteries, is 3.5 kilos. The motor output is about 220 watts, and the continuous torque rating is 30 Newton meters. So the secret behind this technology is the unique freewheel technology. This allows basically the cyclist to be only assisted when required, so it essentially feels like you're riding with a tailwind. The drive unit, as I mentioned, consists of an EC brushless motor, and it can fit into down tubes from 60 mil diameter. Also, the Q factor is 155 millimeter, and this essentially means the system can fit within gravel bikes, mountain bikes, racing bikes, kids bikes, etc. So it's very adaptable. This Bike Drive Air is just basically available for manufacturers. It's not really for individual resale. The Scalable Wheelchair, I thought this one was quite interesting. This is a project that was developed out of ETH Zurich. It was supported through our Young Engineering program, which basically supports young engineers and startups with discounted drives and a good deal of technical expertise. The the wheelchair aims to improve the lives of disabled people and give them the mobility they essentially deserve. Yeah, the Scalable Wheelchair combines two well-known systems into one spectacular device. Rubber tracks offer optimal grip on staircases, stairways, etc. And the sturdy wheels grant mobility and freedom the operator requires as well. So on flat ground, the wheelchair balances on the two large wheels, and it essentially has a zero turn capability. And then when it reaches the staircases, the two tracks fold out to adjust to the angle of the stairs. And the track material was also specifically built to deal with staircases. When you get to the top of the staircases, two small wheels fold out, and this essentially prevents the wheelchair from toppling backwards. Again, just to dig a little bit deeper into this, the wheel motors were supplied by Maxon, and they also contain a GP52 ceramic gearhead. The gearhead is ceramic because it allows for an extended service life, etc. It also uses positional EPOS 70/10 positioning controllers from Maxon. And I mentioned already that the project was supported through a YET program, and the total weight of the Maxon components is about 3.2 kilograms. So finally, I'd like to point you in the direction of some very useful Maxon resources. We have our product catalog, which contains a great deal of technical information at the beginning of the catalog. It's available for download, and you can also get a hardback copy sent out to you. Ursula Farger's book, The Selection of High Precision Microdrives, is a very good read, and it's available for purchase off the website. The Formula Handbook is available for download from the website for free. We also have a resource section on the website, which contains a good few video tutorials, etc., that are very easy to follow. Our Driven magazine is available for download, and we can send you out a hardback copy also. This is available quarterly, and it contains a good few very interesting case studies and a good bit of technical information as well. I've already mentioned the Young Engineering programs a couple of times. This is available through our website also. It takes 2 or 3 minutes to fill out. It's a bit of a no-brainer. Once you fill it out, you'll hear back from Maxon representatives within 1 to 2 days, and they will tell you whether you were successful and what type of discount, and you can basically start receiving technical expertise from our experts as well. So thank you very much. I look forward to fielding some questions, and if you'd like to email me privately, you can with the contact details below on the bottom left of this slide. Yeah, I'd be delighted to field any questions if there is any. And yeah, okay, if there's no questions, thank you to everybody for listening in today. And again, if you want to contact me with the details that were on the last slide privately, I'd be more than happy to have a conversation with you. Yeah, so thanks again to EDS and to Maxon, and yeah, I look forward to talking to you in the future.